In this video, we're going to focus on visualizing our clusters with a package called seaborn. Let's dive right in. So the first thing to do is we want to import seaborn into our Python environment. In in54, much like what it seems every other package in Python data science, we import seaborn as SNS, which is its target shortcode. So you will notice this throughout your data science journey in Python. People import TensorFlow as TF, NumPy as NP, Pandas as PD, and so on and so forth. We first want to set the color codes to true in in54. To illustrate this chapter, I want to show you with the iris dataset, which is arguably the most famous dataset out there. We first call the load dataset function specifying the iris dataset from SNS, and we feed it into a variable called iris. The next thing we want to do is to remove the labels. In in56, we remove the labels by calling the pop function, which is actually just a Python native built-in function that takes away a certain key inside a dictionary. So here we're taking away the species key and we're putting the value of this object into species as a variable. The next thing we want to do is to plot a clustering map of the iris data. In in75, I am creating a new cluster map by calling sns.clustermap. I feed in the data, iris, as our first parameter. I specify that the color map should be Mako. I specify that we need a robust figure. And lastly, I've specified that the figure size needs to be 20 times 15. In a Python Jupyter Notebook environment, we need to call plt.show for this to come up. In this diagram, we can see that the lower the value, the darker the color, and a lighter greenish color shows that the value of this feature is higher. On the left-hand side, we have a diagram that shows us what can be grouped together based on a particular distance measure. And we can see that, for example, petal width occupies the lower end of the range of values, whereas sepal length occupies the higher end of the range of values. The next thing I want to show is how we can use a different metric to cluster these features together. In in74, I am calling cluster map, and I'm putting the metric as correlation. Again, we are specifying the color map as Mako, robust is true, and after showing this plot, everything is the same apart from the fact that on the left, we have a different cluster diagram, and that's because now we're using a different distance measure. Something else that's quite interesting is the pair plots. So here, if we call sns.pairplot and feed in the iris data, we can see a grid, a 4x4 grid, corresponding to how different features correspond to one another. For example, we can see that sepal length and petal width is largely positively correlated if we look at the bottom left pane. It's quite a continuous distribution, unlike, let's say, petal length and petal width, where we can see distinct grouping of two clusters. In the middle, or so-called the diagonal, this is the histogram of the values of the feature. So for example, petal width is concentrated near 0. There's a drop between 0 and 1, and other values concentrate between 1 and 2.5. On the other hand, petal length has two very nice clusters. A big cluster at 2, and another big cluster between 3.5 and 6.5. What if we want to label the dots and the histograms based on the class. In in81, I first set the style to ticks, and again maintain that color codes needs to be true. I load the iris dataset again to get the labels back into the variable, and I call the pair plot function feeding in the datasets, specifying that the diagonal should be plotting the kernel density estimate and not the histogram. I use a hue keyword argument to specify that we need to use the species key in the iris data to color the dots. And I specify a particular XUSL palette to do this. If you look at the chart here, we can see that we still see the same chart. However, each class has been specified using different colors. As you can see here, as a data scientist, the first thing I notice is the class blue and green is very inseparable, right? So regardless of what you look at, they seem to overlap one another, whereas the pink class seems fairly separable. So this is a very neat way for us to understand the clustering and the groupings of our data and use this information to design algorithms downstream. And that wraps up the course. I hope I have brought you through your first steps to Python data science. Keep on learning, and I'll see you guys in my other videos. Thank you.